Welcome to the deep dive. Today we're exploring something critical, kind of invisible, but part of our daily digital lives, front-end testing. Just think about it for a second. One broken button, maybe a text field that's slightly off, or even just a slow page. That kind of stuff can cost businesses millions, right? And drive users like you away instantly. So this deep dive is all about understanding that unsung guardian, the thing that makes sure the digital experiences we often take for granted actually, well, work.
Exactly. And our mission today really is to unpack what front-end testing truly involves, why it's not just, important, but absolutely critical for modern digital stuff. We'll look into how teams plan for it meticulously, the kind of tools they need, and its direct, very tangible impact on your everyday online interactions.
Okay, so let's start right at the beginning then. What exactly is front-end testing?
At its heart, it's about checking the graphical user interface, the bit you actually see and interact with on a website or app, and also the functionality behind it, the usability, making sure it's all flawless. The main goal here is keeping that presentation layer completely free of defects, especially when new updates are constantly being pushed out. So for instance, these tests make sure that when you type your name in a field, it only takes letters, right? It stops those annoying errors before they even happen. Or maybe it checks that every button actually clicks and all the text and images line up properly no matter what screen size you're using.
And it really goes beyond just those basics. Front-end testing digs into things like CSS regression testing. That means catching tiny style changes, things you might not even think about, that could suddenly break a whole layout, turn a nice design into a mess. It also checks changes to JavaScript files. Those can sometimes, subtly or not so subtly, just make the whole front end stop working. And importantly, it includes performance checks too, which we'll definitely get into more detail on later. Ultimately, all this makes sure that you, the user, are, well, protected from bugs and always have a smooth, predictable experience.
Right. Given how complex things are now, all those different phones, tablets, laptops, browsers, operating systems, it feels like you'd need a massive team just to test every single possibility. Is that even feasible? Or do teams have to be smarter about it?
You've really hit on the main challenge right there.
Yeah.
Trying to test every single combination. That would just be a black hole for time and money. It's not practical. And that's precisely why having a solid front-end testing plan isn't just nice to have. It's essential. It's what stops projects getting completely swamped. It helps you strategically figure out exactly which browsers and operating systems really matter for your specific audience, which, cuts down the effort and the cost considerably.
Okay, that makes sense. And the benefits of actually making that plan sound pretty significant. First off, it gives you total clarity on the project scope, right? You know what you're building, who it's for, where to focus. And having that planned, systematic approach must give teams real confidence when it's time to deploy. You can push that button knowing you've done your best to avoid nasty surprises for users.
Exactly. That confidence is key.
So we've established why a good plan is so crucial. Non-negotiable, really. Now, let's maybe pull back the curtain a bit. How do teams actually create these plans? What's the blueprint? The source material lays out a pretty simple four-step process. Step 1, find the right tools to actually manage the test plan itself. Step 2, decide on the budget. How much are you dedicating to front-end testing? Step 3, set the timeline for the whole testing process. And Step 4, define the entire scope of the project.
Yeah, that scope part, step 4, that's where a lot of the really crucial user-focused thinking comes in. It's not just about the code itself. It's deeply connected to who your actual users are. So the scope needs to cover details like which operating systems and browsers your audience uses most. Even things like their typical internet plans or the popular devices they use could be the newest smartphone or an older tablet. Also, their general tech savviness, and even the typical internet speeds they might have. All these things massively affect how your front end feels to them, and so how you should test it.
Those are really valuable insights for planning. Okay, so once you've got that detailed plan worked out, the next logical question is how do you execute it well? Not just thoroughly, but efficiently. That brings us to some practical tips. The source suggests things like planning your budget, resources, and time very carefully. It also recommends using something called a headless browser, which is basically a web browser running without the visual part, right? Like Chrome running invisibly in the background.
Exactly. Think of it like the browser engine doing all the work, loading pages, running scripts, but without actually drawing anything on the screen. This makes tests run incredibly fast because it skips the whole visual rendering step. Much more efficient for automated cycles.
Okay, faster tests. That sounds good.
And connected to that is the idea of cutting down on DOM rendering. The DOM, the document object model, it's essentially the structural map of your web page. Normally, the browser renders it, drawing everything you see. For tests, sometimes you can tell the testing tool to skip rendering parts of the page it doesn't strictly need to interact with for that specific test. Again, it speeds things up, focuses resources where they're needed. Another key tip is isolating test cases. Keep them small and focused. That way, if something breaks, you can find the root cause much faster. Makes fixing defects quicker. And for efficiency down the line, make your test scripts reusable. You'll need them again for regression testing. Oh, and use consistent naming conventions for those scripts. Saves headaches later, trust me.
Right, makes maintenance easier. These aren't just minor tweaks then, they're real strategies for making testing more effective, less painful.
Definitely.
So we have the plan, we have some smart ways to execute it. What about the actual tools?
The toolkit, there seems to be a whole range of them, often grouped by what they test, like JavaScript or the overall user journey, CSS styles, visual consistency. Indeed. Yeah, let's look at a few specific examples mentioned. For JavaScript testing, there's Jasmine. It's what they call a behavior-driven development framework, or BDD. BDD is basically about writing tests using descriptions of how the software should behave from a user's point of view, often in almost plain English. It helps bridge the gap between the tech team and, say, business folks. Makes tests more readable, focused on value. Jasmine itself has a nice clean syntax, not many dependencies, so writing tests feels quite intuitive.
Okay, BDD for JavaScript with Jasmine. What else?
Then you've got Selenium, probably one of the most well-known tools out there. It's mainly for functional testing the application end-to-end like a user would across different browsers and platforms, Windows, Mac, Linux. What's really powerful about Selenium is its flexibility. It supports multiple programming languages like Java, PHP, C#, Python, loads of them. And it has record and playback features, which can be a great starting point for teams maybe newer to automation.
Recording user actions and turning them into tests.
Yeah.
Interesting. What about the visual side, CSS?
Right. For CSS, there's CSSLint. It's an open-source JavaScript tool, pretty much the market leader for CSS linting. Think of linting like a spell checker or grammar checker, but for your code. CSSLint automatically scans your CSS files and flags potential errors, maybe inefficient code, or styles that don't follow best practices. Helps keep your CSS clean and maintainable.
Catches problems before they cause visual glitches? Got it.
And for specifically checking those visual glitches, there's BackstopJS. This is a JavaScript framework focused purely on visual regression testing. You can set it up to take screenshots of your interface across different screen sizes, and then it compares these snapshots against baseline images. It flags any visual differences, even tiny pixel shifts that might have crept in. Really useful for maintaining design consistency.
So lots of powerful tools. Are there any downsides or challenges with using them?
Well, yeah. It's important to be realistic. There are two main challenges often cited with front-end test automation. First, getting automation set up properly. It takes a significant amount of effort up front. Time, resources, expertise. It's an investment. It pays off long-term, definitely, but it's not an instant solution. And second, you can sometimes run into compatibility headaches. Ensuring your tests work reliably across all the different operating systems and browser versions you need to support requires ongoing maintenance.
Okay, so it's powerful, but needs commitment. That makes sense. That covers testing the functionality and appearance really well. But, even a perfectly working app can fail if it's just slow. Which brings us nicely to the next big topic, front-end performance optimization, the need for speed. When we talk about this, we're basically asking how fast does the page actually load and how quickly does it respond when you click something? It's generally considered good practice, isn't it, to optimize performance for just a single user before you start worrying about how it handles thousands of users.
Absolutely. Get the baseline right first.
Yeah.
And historically, performance optimization was mostly a server-side concern. Early websites were simpler, more static. Most of the heavy lifting happened on the server. But here's where things got really interesting. With Web 2.0, applications became much more dynamic, much more interactive. Suddenly, all this code running in your browser, the client-side code, became a major factor in performance. Sometimes, honestly, a real performance hog.
Right, so the focus shifted.
It did. And this leads to a fascinating point, kind of an aha moment about where you get the most bang for your buck with optimization. Studies have actually shown if you manage to improve your backend performance by, say, 50%, you might see the application's overall speed increase by maybe 10%.
Okay, 10%.
But if you improve the front-end performance by 50%, you could potentially increase the overall application performance by a massive 40%.
Wow, 40%. That's a huge difference, 4 times the impact.
It's huge because the user directly experiences the front end, the loading, the clicks, the animations. So improvements there feel much more significant.
And that really underscores why focusing here is so critical. Plus, the practical side is, it often seems that optimizing the front end can be, well, easier and maybe more cost-effective than trying to do massive re-engineering on the back-end systems.
That's often the case, yeah.
Hmm.
You can get big wins with front-end tweaks. And naturally, there are tools specifically for this performance optimization side, too. PageSpeed, for instance. It's an open-source tool from Google. It analyzes your web pages and gives you concrete suggestions on how to make them load faster. Things like optimizing images, reducing file sizes, helps pages get retrieved quicker.
Actionable advice. Good.
Then there's Pingdom. This is more of a comprehensive website monitoring service. It helps you examine all the different parts of a page load, gives you performance reports, tracks performance over time. And a really useful feature is that it lets you test your site's speed from different locations around the world. So you see how it performs for users everywhere, not just near your server.
Gives you that global picture. Very useful. Okay, so to kind of bring this deep dive together then, front-end testing at its core is about checking that GUI, the functionality, the usability, making sure it's all working smoothly for a big free user experience. And creating that solid testing plan beforehand is absolutely key. It clarifies the scope, builds confidence, makes sure you're testing the right things for the right users.
Exactly. And let's really underline that point about front-end performance optimization again. As we saw, improving the front end can have this disproportionately massive impact on the application's overall speed and responsiveness, often much more so than comparable back-end improvements. And that translates directly into happier users and a more efficient application.
It really does. So here's something to think about as we wrap up. Given how much we all rely on these smooth, fast digital experiences every single day, what does that disproportionate impact of front-end optimization really tell us about where innovation, where effort might best be focused for the future of the web? Something to maybe mull over next time you're clicking around your favorite sites. CSS Academy Podcast, where ideas ignite and futures form.